Why is the parallel postulate famous in geometry? Imagine trying to build a perfect straight line that never crosses another line no matter how far you extend it. Sounds simple, right? But in geometry, this idea is more complicated than it seems. The reason is that this simple statement, called the parallel postulate, has puzzled mathematicians for centuries. It is one of Euclid's 5 basic rules or postulates that help us understand shapes and space. The first 4 postulates are quite straightforward and easy to accept. But the 5th one, the parallel postulate, is different. It talks about how lines behave when they are extended far out. It says that if you have a line and a point not on that line, there is exactly one line through that point that will never meet the original line. This idea sounds simple, but proving it from the other 4 rules was very difficult. Many mathematicians tried to do it for hundreds of years. They believed it might be possible to prove the parallel postulate as a theorem, which is a statement that can be proved from other rules. But no one ever succeeded. This made the parallel postulate stand out as an axiom, a rule accepted without proof. Its importance grew even more when, in the 1800s, mathematicians started to ask, what if we change or reject this rule? They found that if you alter the parallel postulate, you get new kinds of geometry. These are called non-Euclidean geometries. In hyperbolic geometry, many lines through a point do not meet the original line. In elliptic geometry, no lines are parallel at all. These discoveries showed that Euclidean geometry is just one way to understand space. It is not the only way. The parallel postulate is also key to many properties we learn in school. For example, it explains why the angles in a triangle add up to exactly 180 degrees. It helps us understand how parallel lines work and how shapes like circles and polygons behave on flat surfaces. Its fame comes from the fact that it was so hard to prove, yet so essential to the entire system of Euclidean geometry. When mathematicians explored what happens if the rule is changed, they opened the door to new worlds of mathematics. These new geometries are important in science, especially in understanding curved spaces like those in Einstein's theory of relativity. So, the parallel postulate is famous because it is a simple idea that shaped the way we think about space, shapes, and angles. It stood as a challenge for centuries and led to discoveries that changed the way we see the universe.